Good morning to our lecturer, Dr. Safiza, and my fellow friends. Today, me and my group are here to present the engineering analysis about our greening product, which is motorized cobweb greener. First, I would like to introduce my teammates who are paid their whole effort and time to complete this project successfully. And the top left is our leader, Farhan, and me at the center, Lau Eng Xiang, and Fidaus, Dalila, and Natra. This is the detailed design of our product. Number one is the extendable aluminum pole. It can extend up to 4 meters long and it helps the user to reach higher places like ceiling and the corner. Number two is the main component, the motor with high torque. It produces rotational force and make the brush rotate. And the rotating brush will make our greening process more efficient and hence save our time. Number three is the screw that lock the motor on the place. Number four is fan wiper. With the long pole, it can clean the ceiling fan too loudly. Number five is the modern push button, and number six is the charger port to charge our rechargeable battery. Number seven is trapper. The function of the trapper is to trap the dust and the cobwebs, something like dropping that fall from ceiling. It avoid the droppings fall onto user eyes. Number eight is our rechargeable battery. It can save cost because it can be recharged many times before it need to be replaced. And number nine is the battery cover. Number 10 is the brush, which is our main component, and the pen roller. The brush, pen roller, and fan wiper are interchangeable based on customer need. The following slide, I will show you some calculation regarding to our product. For the motor part, we bought a motor with 0.185 ampere and the voltage is 12 voltage. And with that, we can get the power, which is current times voltage, and we will get 2.22 watts. And for the efficiency, after we measure the working output and with the working input that we calculate from the previous part, we can get the 0.91, which is 91% of efficiency, which is quite efficient. And now we will calculate the torque. To calculate the torque, we will first to know the angular velocity, which is omega. In omega, we know that there are 100 revolution per minute. Then we will times 2 times over 60 in order to convert it into radian per second. And with the omega we calculated, we can know the torque after we divide the power by omega, and we will get 0.212 Newton meter. And for the stress, we assume that there are 1 kg acting on the motor, so which is 9.81 in Newton, and we divide with the area of the motor, and we will get 1601.37 Newton per meter square, which is in pressure and is Pascal. And for the extendable pole, we will calculate the pressure at the pole. And for the pressure, we assume there is 10 kg of grip force acting on the pole, then is 98.1 Newton over the area of the pole. We will get the pressure 129.147 Pascal. Well, for the torsional shear stress, the formula of the torsional shear stress is tau equals to Tc over Z. And first we will calculate the torque, and we will get 80 Newton meter, and then we sub the value that we know the, and for the C is 12.5 millimeter, and for the polar moment of inertia, then we sub it in and we will get 26.08 megapascal. And the last one is factor of safety. For the formula of factor of safety is the ultimate stress divided by the actual stress, and we will get 11.88, and is quite safe for our product.
Okay, now for the finite element analysis, we have done two methods for this analysis, that is static structural analysis and the thermal analysis. For the static structural analysis, we use it to determine the effect on a physical structure while the load are applied on it. Okay, for the first part of analysis is a brush. For the body of the brush, we use the plastic material, and we apply the load 0.249 on the top of the brush, and we apply the feed support on the bottom of the brush. And now we can see the result of our analysis, that is the total deformation. This total deformation shows the maximum and the minimum deformation that will occur after the load are applied. And from the scale, we can see that maximum deformation will occur on the edge of the body, and the minimum deformation will occur on the bottom of the body with the blue color, and the maximum deformation with the red color. And then the second result is the equivalent stress. We can see that the green color is the maximum for the equivalent stress that occur on the top of the brush, on the top of the body, and the minimum equivalent stress at the bottom of the body with a blue color. And then for the elastic strain, it shows the top of the body will occur the maximum strain with the green color, and the bottom of the body shows the blue color with minimum strain. And then for the safety factor, we can see the scale are still 0 until 1 for our analysis, and we can conclude that this brush are safe to use. And then the second part of our structural analysis is the extendable pole. This extendable pole are built from the aluminium alloy that is very strong and light in weight. And we apply the load 0.249 at the top of the pole, and we apply the feed support at the bottom of the pole. And then we can see the result of our analysis is that is the static displacement. For the static displacement, it shows the maximum displacement will occur on the top of the pole, and the minimum displacement will occur on the bottom of the pole. And then we go through with the equivalent stress that we use is the von Mises method, and we can see the maximum stress will occur at the bottom of the pole, and the minimum stress will occur on the top, at the top of the pole. And then in this scale, we also can see the yield strength of the pole, that is 0.235. And then for the static strain analysis, we can see from the animation that maximum strain will occur at the bottom of the pole and the minimum strain will occur at the top of the pole. Okay, for the safety factor, we can see that our pole are in the red color, and then the scale shows the red color are the lower safety factor, which means that is very suitable and very safe to use for our product. And then the third part for our analysis is a screw, that we use the titanium for this screw as a build material, and we apply the force 0.249 at the top of the screw and the feet support on the bottom of the screw. Now we can see the result of our analysis, that is the total deformation. It shows the maximum deformations will occur on the top, and the minimum deformation will occur at the bottom with the blue color, and the maximum deformation with the red color. And then the second result is the equivalent stress. It also shows the maximum stress will occur on the top, and the minimum stress will occur with a blue color at the bottom of the screw. And then we go through with the elastic strain analysis, that shows the green color is the maximum of the strain, and the blue color is the minimum of the strain. And finally is the safety factor. Safety factor of our product are in the scale 0 until 1, and it also shows that it's very safety to use.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cikgu Muhammad Farhan. Today I would like to present about thermal analysis. Thermal analysis is a branch of materials science where the properties of materials are studied as they change with temperature. Several methods are commonly used. These are distinguished from one another by the property which is measured: differential scanning, calorimetry, heat flow change versus temperature, or time function. To perform thermal analysis, firstly, we must create a thermal study. Second, define material for each solid and shell. 3. Define thermal load or restraints. 4. For transient study, you can define a thermostat. 5. For assembly and multi-body parts, make sure to define the proper contact setting. 6. Mesh the model and the study. Finally, view the result. The analysis temperature is to show the temperature when it's running. The range temperature for battery when it being used is between negative 20 degrees Celsius until 60 degrees Celsius. But for analysis, we take average temperature, which is 40 degrees Celsius. As we can see, for the red in color is for the maximum temperature, and for the yellow one in color is for minimum temperature. Directional heat flux is a flow of energy per unit of area per unit of time. As we can see, for yellow in color is for maximum heat flux, and for green in color is for minimum heat flux. Total heat flux is amount of the heat transfer per unit area per unit time to or from a surface. As we can see here, for the light blue in color is for maximum total heat flux, and for the dark blue in color is for minimum total heat flux. For the motor, then the temperature of the motor when it operates is from 0 degrees Celsius until 100 degrees Celsius, but for this analysis we take 60 degrees Celsius. As we can see here, for the maximum temperature is in red color, and for the minimum temperature is in blue color. For the directional heat flux and total heat flux, for the maximum temperature is red color, and for the minimum temperature is blue color. I think that's all from me. Thank you.
So now we go through to the project management and finance section. To start the project, in the first week, we started with being prepared all the items needed as list with the budget. Then we surveyed the workshop environment before started our project, and we also ensure all the tools in a good condition. We also do the cost analysis by doing the price comparison and make sure that we can get the right material with the affordable price. For the second week, after doing the comparison price session, we decided to purchase the extendable pool, brush, paint roller and screw at Mr. DIY stores. In the week 3, we purchased modern push button, rechargeable battery and charger port at ProSign Electrical and Electronics. For DC motor, we purchased through online by using Shopee websites. After that, we started fabrication in the week 4 until week 6. We fabricate the trapper, fan wiper and battery cover. By the following week, we had presented our prototype, completing report and finally submit the report including the videos. So this is our Gantt chart for the project. We started to purchase our items in the middle of February until 18th of March. It's been more than a month since we purchased some of the items from the overseas. Then in the engineering analysis, it was carried out since February until 23rd of May. Next, we were able to prepare half of the prototype before the movement control order was executed starting at the 18th of March until today. Then we do the analysis, progress presentation and animation video. Start from the 15th until 28th of June. Last but not least, the project presentation and report submission were submitted before 3rd of July 2020.
Next is finance. We purchased aluminium pool from Mr. DIY. The aluminium pool is cut, fabricated and assembled. Next, we purchased modern push button, rechargeable battery, charger port from ProSign Electrical and Electronic Hardware. We also purchased brush, pen ruler from Mr. DIY and also screw. Then we purchased DC motor from Shopee. The price for extendable pool is RM25, switch button RM12, rechargeable battery RM70, Battery cover RM10, motor RM100, charger port RM75, transparent wrapper RM15, fan wiper RM8, paint roller RM20, screw is 57 ringgit each. We purchased 4. Brush RM10. The total of all these items is RM347, which is make it affordable and within the budget. The conclusion is the motorized cobweb cleaner is upgrade to overcome and solve the problem faced by the user during the cleaning process of cobwebs. The existing device make it less efficient and difficult for user to handle the tool. So by using aluminum, it is much lighter and easier to handle compared to the current device. This project comes with advantages and disadvantages of motorized cobwebs cleaner. There are still many weaknesses on the design and material usage. The product needs more improvement in many features. There are some improvement and recommendation that can be done, such as stretchable part. The material should have more durability, and the polyester will lose the stretch ability in a short time. So the design of the bulb holder must be controlled by a spring to hold the bulb. By using spring as mechanism, it will much easier to pull the holder using a cable. That's all. Thank you.